Afternoon, everybody. So thanks so much for trekking over to the Mandalay Bay and joining us this afternoon. One of the last sessions of your week here in reInvent. Today, before we head off, we are going to spend a little time thinking about one of the toughest challenges in doing software at scale. How do we balance the freedom that developers need to innovate, to do new things, to get stuff in front of their customers, and the consistency that we need to actually operate and manage things at scale and stay efficient as we bring more and more teams on board. My name's Matt Mekis, and I'm a serverless specialist here at AWS. I've spent most of my life as a developer, so as a Java developer and a .NET developer, and I'll be kind of talking through a little bit about what my journey's been like as we've been on this transition from kind of traditional models to the cloud. I'm going to hand off to my colleague Roland, who's our director of all the specialist SAs and technology teams here at AWS. He's going to be talking a bit about the evolution of infrastructure and how we blend these things together. And then we're going to finish up with Dave, who's been doing some amazing stuff to build a serverless first, well-architected platform engineering culture at Globalization Partners. So he's going to take some of the theory that Roland and I are talking about and actually show you how we put that together in practice over at GP. So this year, I've got my little pin on. It's the 10th year anniversary of Lambda and ECS. This year, 2 years before we launched those services, Werner was on the keynote at AWS and made this bold statement that in the future, you'll only write business logic. And a lot of what we've been doing at AWS is sort of aiming towards this idea that we can really refocus on the stuff that drives value for our customers and not think about all of the undifferentiated heavy lifting that's part of building enterprise applications. So a lot of what we're talking about is this evolution of our operating model. So when I started my career, we were very neatly in two different buckets. We had application development teams who wrote code, and that's where I sat. I'd write a Java application, I'd compile a jar, maybe have some database scripts. I'd hand it over the wall to our infrastructure guys, and they'd go and run those applications for me and manage them in hardware. And the serverless revolution has changed the roles of some of those teams. So we've started to take on responsibility for the hardware and the infrastructure, compute. Maybe we're using cloud-native databases. So the responsibility of those infrastructure teams have changed, but also the responsibility of developers have changed. It's gone hand in hand with this kind of DevOps revolution. So we talk a lot about two-pizza teams here at Amazon, and the idea is to have small, nimble, decentralized teams that are mixed with dev people and ops people, DevOps people who are focused on a singular goal and have a lot of autonomy, and they're building and running stuff. And that's all great, and it sounds brilliant. What does that mean in practice? When I started my career, I was writing code, compiling a jar, handing it off to go and get run. We then started doing some continuous integration, continuous delivery. I was then having to write scripts to go and build and deploy my functionality. Now I'm deploying my functionality. Now I'm responsible for it, and I'm doing it on my own schedule. I suddenly had to start running it, so I had to start getting on the on-call register and starting to look after this stuff in the cloud. And the security model started to move to the cloud. It went from being a world where security was something that a security team thought about at the perimeter, and as long as I was deploying into the network, everything was fine, to actually being something as a developer. I had to think about what IAM policies I was using for fine-grained access control between different modules of my application. Serverless happened, that's great. I've now got nearly limitless compute and resources on demand as a developer to do whatever I want. So suddenly cost went from something that our infrastructure team had to think about to something that I had to think about as a developer. So am I being efficient with this stuff? Am I using thousands and thousands of Lambda functions when I could be using just a couple? And then of course it's 2024, nearly 2025. We really have to all be thinking about being responsible and how we're going to be writing sustainable code. Are we using Graviton? Are we using the right database provisioning models in order to be green? And so that promise that Werner made of, hey, you've only got to write code, I've suddenly got into this serverless universe, and I've got all this additional cognitive load I never had before that I've got to deal with to ship code. And so that's the real challenge. How we navigate that is really complicated, and some of the solutions for that come from platform engineering. So when we're organizing for innovation, just saying we're going to have two pizza teams is a great idea. It's important, but it's not enough. So some of the other things that you have to think about, what's the culture? Are we hiring the right people? How are we supporting people and giving them somewhere where they can experiment and fail and be confident, psychological safety? What architecture are we providing them? What are the kind of blueprints and tools and technologies we can use so that they can innovate quickly? I really wanted to double down on a couple of those points. One of them is mechanisms. Well, all of that breadth of cognitive load, how can we make it easier for engineers to come on board and distill down the bits they really should care about and automate away the bits they shouldn't have to worry about? And also, beyond just a two-pizza team, what do these organizations really look like? How do we start to structure our teams? What are the functions of our teams and what are our interaction modes? So one of the mechanisms I think is really, really valuable is the well-architected framework. So if you look at the pillars of the well-architected framework, it really aligns with all of the topics that become part of the cognitive load of being a modern cloud developer. I think a lot of people think about the well-architected framework like it's an audit. We have to go through this process once a year or before we release to production. And then we get sort of told off for not being well-architected enough. I think that we should really rethink this and actually build a lot of these pillars into our kind of enabling part of our life cycle. So as we're onboarding new teams, maybe a team hasn't done security threat modeling, how can we kind of coach them to get used to it? How can we make sure that our developers get that breadth across all of the pillars? And so Dave's going to talk a bit more about how they're using well-architected in a really light touch way as part of their agile delivery process when he talks about what they're doing at GP. But super, super powerful process and takes away a lot of that cognitive load. We also have to build on that two-pizza team concept. So I think two-pizza teams are super important and a big part of how you are successful in an innovative software culture. One of our former VPs, a guy called Dave Limp, said a lovely quote, which if you want to fail at something, make it someone's part-time job. And the two-pizza team is really trying to get away from that. So we know exactly what we're doing. We're really, really focused on that deliverable. But it isn't a lot. It isn't everything that you need to be successful. So I like to also think about how that applies in this team topologies model. So something that we see a lot of people starting to adopt as they're building out a platform culture. So alongside those stream-aligned teams that are focused on a single bit of customer value, you might also have a complicated subsystem team. Maybe that's slightly more abstract from a direct value stream. So maybe you've got something really difficult that needs a whole bunch of maths. You've got a really, really complex international payment system that all of these other teams depend on. Maybe you need to isolate that in a subsystem, and that subsystem can then be exposed in a as a service model, so other teams can consume it without having to have a whole bunch of meetings and interactions in order to do so. I also really like the idea of a facilitating team. So facilitating team is coming on board and coaching and encouraging teams to get up to speed as they are improving their maturity working on the cloud. In the cloud. So you might have a team that specializes in security who's not running threat modeling for you, but is coaching a team to start to do threat modeling. So they might come in the first time you shadow them to threat model your piece of software. The second time they might reverse shadow it. And then the third time you're doing it on your own and maybe calling in for support on a particular element of it. And that facilitating team, as they are upskilling that one team, they might move on to support another team. So within the team topologies model, there's four fundamental topologies. There's stream-aligned teams that we've talked about, these enabling teams who are helping people to get up to speed, complicated subsystem teams. I sort of skipped over the platform team, this big heroic team, because I'm going to let Roland dive deep on the detail of what that means. But these fundamental teams are really designed to help us improve the flow of change. So what we really want to do is have these teams, as we scale, able to deliver stuff from left to right, from an idea to being in front of a customer as quickly as possible. And that's really all set up to make the you build it, you run it, stream-aligned teams succeed. And so it's really important those teams aren't handing off to somebody else. They're not getting to a certain stage in their process and having to hand off to another team to then move it to production or to do your threat model. They should really be owning that entire process. So everything else is about empowering them, upskilling them, enabling them to have total ownership of that entire journey. I also think it's really interesting to sort of be quite deliberate about the interaction modes between those teams. So in the team topologies model, there's only 3 interaction models that you can have. You're either working together on the same project, delivering something in a collaboration mode, or you're providing it as a service, and if it's as a service, it should be as self-service as possible, so a team can come along and they can consume that thing without having to have a whole bunch of meetings or discussions for doing it. They can just go to your developer portal, look at the documentation, and integrate it into their service. Or it's a facilitation mode where you're coming along and you're coaching another team to deliver a piece of functionality. And so part of that is all about enabling these application teams to deliver all that rapid innovation, agility, feedback, deliver new services. Of course, my colleague here, Roland, really cares about actually consistency and infrastructure and how we keep us safe, so I'll let him talk about that side of the puzzle.
Matt. How's everyone doing? Everyone looking forward to the concert tonight? I think Weezer and DJ Zed, I don't know who that is, shows the age. We need things to look forward to. As an infrastructure person, through the day, I get a lot of hate from Matt, the developer, because we have sometimes what seems like conflicting goals. He wants to build new applications, deploy them to the cloud fast, a bunch of new stuff he wants to do all the time, and he doesn't understand that I have to worry about things like performance, security, consistency, standards that I have in my compliance organization, et cetera. And so we oftentimes have these colliding concerns. Not that he's not concerned about some of those things, but I have to think about it from a perspective of all the infrastructure needed to support the applications he wants to build. Every one of Matt's apps uses a different database. I don't know why he can't use the same one, right? He wants to use queues and topics. All of these things have different security and scaling needs, and therefore, I've had to kind of scale him back and make him do things like open a ticket, et cetera. Well, the problem becomes that he's not the only one. He thinks he has the best app in our organization. However, we have all these different teams, and they just come at me, and I get all this hate because I've become this bottleneck. Now, there's a bunch of new stuff happening in my organization. They want to build AI applications and Jupyter notebooks. They say, hey, just give me access to data, and I want to run these complicated batch things and parallel data processing. And all of a sudden, got this bill for this thing, GPU, and then I couldn't even find these GPUs anymore. So now I have to worry about things like GPU. There's all new types of automations and data pipelines and processing. So things have become a lot more stateful when it comes to these applications. So of course, we kind of came up to the point where we said, you know what? We have DevOps, and DevOps solves all problems, right? As long as you have a CI/CD process, your organization should run smooth. Every application should be deployed. And so DevOps will have this stuff, and we'll standardize on a set of tools, and then we have my infrastructure as code. I can add some automation. I can use things like CloudFormation, CDK, Terraform to provision my infrastructure. Now, instead of having these teams come at me with different applications, now we have these automations. The problem is it's a lot of stuff for me to manage. See, the business gives all the resources to the application development teams because they're creating new things and new businesses. Oftentimes, these platform teams are seen as a cost, something that's needed to support and just get the job going. So I want to be nice. I know he wants autonomy. I know he wants freedom. So we shift left and give more control to these development teams. And so Matt is building applications with ClickOps and CI/CD, getting lots of stuff. He's down there green. But of course, when I give this freedom, now we have all these different types of tool chains and pipelines. So I have this other organization using something called Kubernetes, EKS. They want to use GitOps, some octopus-looking things called Argo CD, right? All these different tools, or Flux. And then this other team is like, well, I'm building Jupyter notebooks. I have an ML ops pipeline to deploy these data models and things like that. So now I need to end up managing a lot of different workflows, lose track of where things are in the deployment process. We have developers developing code, maybe some application configuration with YAML or JSON. They have architectures, Git repos. They might deploy it into something called Kubernetes, or they might deploy it as Lambda. They might deploy it into ECS. So you have all these different things. I have my ticketing system for resources. Deploying things, and the database team is starting to provision these things, so they might provision with Terraform. And maybe we can standardize on Terraform in this organization, and we can do things like Kinesis. So we have different teams, and we have disjoint workflows. And so how do we solve for this? Okay, so how do we strike the balance between developers and data scientists, data engineers, freedom, standardization, and really making sure we get security, performance at the best cost, observability across the systems? The other issue is that all of these projects don't share the same timeline, right? You have projects that are in the early phase, explore, so we have teams that are not sure what they're going to write Gen AI applications for yet. They're still evaluating different large language models. They're still figuring out what apps, so they need to explore it, make the right choices. At some point, you make decisions, you make architecture decisions, and you build out. When you build that out, you start scaling, and then you get customers using these applications. More customers you get using, you have to sustain it. You have to make sure that you bump up the ilities. And then you may retire applications at the same time. The applications that were written 15 years ago are being rewritten, refactored into microservices, or rewritten with the strangler pattern out as new services. And so we have different life cycles to manage as well. Say the more you're on the left, the more freedom. My left, your right. No, your left. I think we're good. And then the more you go to the right, you get more and more stability. Sometimes changing things can become an issue. We often see different types of organizations are at different levels. Oftentimes startups might be very scrappy. They might have a lot of autonomy. Their infrastructure and platform teams are the same as their development teams, and they build applications. When you get to kind of enterprises and go through SMB all the way up to enterprises, and you get highly regulated enterprises like in finance industry, public sector, et cetera, right, you tend to get more standardization as well. So one of the things that has emerged over the last few years is platform engineering. Platform engineering is really a concept around thinking about, and this is a definition from Luca at Humanitech. There's lots of different definitions for platform engineering. But it's really, I think about it as thinking about your platform as a product, almost like an application. And that application has users. Those users are Matthew, developers, data scientists, creating workflows and APIs that have some of those standard security baked in as automations, are available as APIs, and allows kind of developers more autonomy, more self-service to use these patterns. And so we get into a situation where we have now the two pizza box team concepts, analogy that works well where I'm from in Jersey, where some of the best pizza in the world is from New Jersey. Doesn't work well with the Chicago, I don't know what that thing is, deep dish I think they call it. But the platform team as another two pizza box team that's providing a platform for, as an API for your developers, and also part of the enablement team. How would the platform stack look like? Well, there's different ways to build it out, depending on what types of standards you choose in your company, right? But they more or less cover the same types of things. There's a lot of provisioning and automation around security, delivery of code, observability. Tendency is one big issue we're going to talk about momentarily. Networking, how you make calls, the types of services you're going to use, and your account strategy, landing zone, infrastructure as code best practices. And we're going to get into what's called often a developer portal or a data science portal, internal developer portal. There's different names for it, where you provide user interfaces to these automations that can be easily consumed by development teams, and also a catalog of third parties. There are challenges for platform teams. One is ownership. Oftentimes, platforms is viewed as the supporting thing versus a dedicated project team that's able to own a product and deliver a product. And so it's very important to have that mindset of ownership, single-threaded owner, for the platform like you would any application component. Level of abstraction is another one, and I'll go deeper in a moment. But the level of abstraction between the developers and the platforms, because people are people and they disagree. And so, do we give out accounts with a set of services? Do we give out clusters? Do we provide code as a service, platform as a service? Oftentimes, organizations debate these things. Adoption. Oftentimes, people build this internal platform, and they don't build in a product mindset. They don't work with the developers and data scientists that are using the platform. If you build it, they will come, right? Build this platform, work with a customer that spent a couple years building out this central platform to enforce some standards, and they were getting trouble from lines of businesses using to use the platform just because they hadn't really thought about the workflow. The opposite problem, we sometimes build a platform for users and we say, we're gonna abstract out a bunch of things to a point, and then an issue happens in production, usually the first one to get the pager call and you see, or the notification in Slack or whatever, right? And I'm like, oh, I don't give it to the developer, and the developer's like, oh, pod, whatever. They have to know things about the environment to troubleshoot. So they think about build, but they don't think about run. And so these are some of the top challenges. We're talking about design patterns, right? Oftentimes, these are some of the patterns that we see. Customers employ, account as a service. This is very important, getting your account strategy with AWS and an organization right. How are you going to give accounts to different lines of business, et cetera, get the right guardrails, get some cost management, et cetera. Sometimes it's template as a service. We talked about what makes up a platform where you provide these automations. Sometimes you're providing clusters like either an EKS Kubernetes cluster or a Kafka cluster or some type of hyperpod cluster to run Spark jobs or run ML jobs. And then there's platform as a service where you kind of lean into a code type of environment and say, here's a deployment unit in Java or Python or something like that. We're also seeing permutations of internal platforms. I presented 2 days ago, it's on YouTube already, with Apps Flyer, and they talked about building a default set of platforms for their microservices. So if someone deploys a microservice, it goes to a set of default infrastructure, default clusters, but then they have some users that spin up analytics and they stand up a whole different set of infrastructure pieces for them in a platform like. So they're creating specific ML or an ML or data platform. And we're even seeing industry type platforms being created. This is when we talk about one of the best practices that you should remember is you have good default patterns and you build escape hatches for some of the new innovations, et cetera. It's very important to get your multi-account strategy right. I talked about that already. This is an example of segregating by lines of business, also including workflow like sandbox, new development, et cetera. We have to get that right. Last thing I'm going to mention is one of the kind of emerging trends is the use of a developer portal as part of that platform. Backstage is actually a very popular developer portal technology that's part of the CNCF, which is created by Spotify, actually provides a lot of great features around the software catalog, a set of templates, a set of best practices, documentation as a service, and really hook points to kind of provision your templates. And so Backstage is often used as providing a product face for your platform. Now with that, I'm gonna hand it over. I'm just gonna say, Dave Anderson, right? Even though I'm still a young guy, maybe like 15 years ago, very early in my career, maybe mid in my career, I worked with Dave on a project, and some of these old problems are new, old, right? Where we built out Java middleware infrastructure and integration middleware infrastructure to support his line of business. And now, 15 years later, working together at AWS, so it's like full circle for me, an emotional moment. So with that, I'd like to hand it over to Dave Anderson. So you got a Jersey accent, we went from Europe, back to Europe again, all right? Here you go.
Thank you, Roland. Thank you. I'm not giving you a hug, okay? Good afternoon, folks. So yeah, 15 years ago we worked together, and I want to explain some of the mechanisms that we're still working on. I've probably spent the last 15 years coming up with these mechanisms, and a lot of them have been kind of named around platform engineering. So my name's Dave Anderson. I'm a director of architecture with Globalization Partners, and I'll kind of talk through what we're actually doing around kind of platform engineering. I'm also the author of this book called The Value Flywheel Effect. It's kind of been called the Handbook for Cloud Modernization. And myself and Roland 15 years ago were working on Liberty Mutual. And myself, Mark, and Michael, a lot of the lessons we learned in driving a serverless first strategy with the large company, Liberty Mutual, I kind of wrote that up as the value flywheel effect. There's several kind of case studies in the book, and it's kind of, it's really starting to see that kind of momentum and how we actually create that movement towards what I would call modern cloud in companies. There's also a really nice foreword by Simon Wardley and Adrian Cockcroft. It's published on IT Revolution, which is the same label as, it's Gene Kim's label, same label as Team Topologies, Accelerate. So if you're thinking about this journey, I would definitely look at the IT Revolution suite of books. The value flywheel itself, I think, is quite straightforward. The main idea is joining business and technology strategy. One of the things that always frustrated me was that we would talk about the business. We're going to do what we need to do, and the business is separate. It's a single thing. It's a single thing. If you can sit and really harness the power of what your business need to what your engineers need, you'll create that momentum. And there's 4 phases. The first is clarity of purpose. For me, there's nothing more frustrating than speaking with a team, and they don't really know why they're building what they're building. So one of the mechanisms I like to use is the North Star framework, is to make sure that the team are crystal clear on their functional and non-functional KPIs. The next phase is challenge. You want to create that psychological safety for the team so they understand that they own their workload, they own that problem, they have full autonomy to do what they need to do. So in that there's nothing worse than having a team who are constrained in the wrong way. The next is next best action. And for me, this is the serverless first technology strategy. How can we allow the teams to move as quickly as possible, create flow in the teams, and then finally long-term value. You don't want teams building stuff and then having to throw it away. So using the well-architected framework as a standard, as a technology standard, really helps the teams build in quality. And I find when you visualize your work in this way, you start to spot inertia. What are the things that slow down? And once you start to get the momentum of this framework, you'll see things really move. And I've seen this work in many companies. I'm currently working with GP. GP is a very interesting company. It's the recognized leader in global employment. And so the main product for GP is what's called EOR, Employer of Record. Now, 2 years ago, I had no idea what this was. So let me just explain it to you. If you're a company here in the US and you want to hire, say, me in Ireland or someone in France, today you have to set up an entity in that country and figure out all the local kind of rules in that country. The Employer of Record category means that you can approach a company like GP, say, I'd like to hire this person in, say, Ireland or wherever, Australia, Brazil, Thailand, doesn't matter. And GP will do all the compliant hire of that professional, their salary, compensation, benefits, insurance, tax, everything is handled by GP. So you're a fully badged employee of the company, but GP will handle all the actual legal employment aspects. So, and what this really enables anyone to do is you can hire anyone, anywhere in the world. And GP actually created this category, which is why it's so exciting. It's a real kind of scale as the business grows. There's entities in probably over 100 countries, and there's over 180 countries that are supported. So you can literally, it's just really supports globalization. And one of the reasons that works is because there's a lot of HR and legal experts that help with the compliance and the advice. So there's currently over 1,200 employees in around 40 countries. So we're a remote first company, which again, we're eating our own dog food. And really where the software comes in is how we kind of scale that system. And our big differentiator, I would say, is our compliance. I would say compliance from a technology perspective, we're fully on AWS. And second, compliance from an employment perspective, because we're employing and paying professionals and contractors and giving people advice. So we need to stand by what we do. So it's a really interesting kind of problem and definitely a great technology problem. So for me, as we talk about platform engineering, one of the things I think about is the dichotomy of platform. There is a symbiotic relationship between the application dev team and the infrastructure team. Guys, you need to talk to each other. One can't survive without the other. That's how it is. And you see, I mean, there's a pendulum swing between these two teams. If the app team have too much their way, you're going to have issues with run. If the infrastructure team have too much their way, then you're going to have a constrained development team who will not be happy. So that pendulum swing, it's really hard to get that balance right. And that's why it's a collaboration. There is no one size fits all. So it's really hard to kind of make that balance work. It's the same with any platform. So for me, I would think of what are the platform engineering needs? I think you need to consider the whole system. By that, I don't just mean that the infrastructure or the applications. I also mean the teams. What do we mean by value? What's the flow? You need to have a holistic view of our kind of how we create software. I think you need to have a very good standard around what good looks like. And for me, that's the well-architected standard. There's hundreds, if not thousands, of solution architects who have put their best practice into this framework. Let's just use it. And then fast flow. I want the application development teams to have no constraints, no barriers, to move as fast as they can. The only people who I want to slow down the teams are the actual product management who are trying to figure out what do we need to do. I want to spend all our time thinking about the business problem, and the technology problem is effectively solved. So I want to kind of frame this bit with kind of four sort of sections. The first one I think is, I love this quote by Jerry Weinberg. This is a quote from 1985. No matter how it looks at first, it's always a people problem. You've heard this a million times, and I mean, this was no different 40 years ago. So we talked about team topologies. Emmanuel Pa, one of the authors of team topologies, shared this platform manifesto back in September at the Fast Flow conference. I'm not going to read through this, but at a platform engineering event, talking about the platforms, the first thing he calls out is teams and interactions over tools and functionality. This is not about writing Terraform scripts. It's about how teams and interactions work. Being open to change and collaborating, that's that symbiotic relationship between app dev and infrastructure. And you've got to think about who are the actual users of platform engineering. And really it's about, and I love this line at the end, unblocking internal customers via self-service patterns. I think that's really and that's very difficult to do that. Certainly in my past, we had, before kind of Backstage came along, we had several attempts at building IDPs. We tried the infrastructure heavy one, didn't work. We tried the developer heavy one, didn't work. It was a self-service model that really gained traction and continues to. So let me talk you through the sort of system architecture within GP. So probably about 4 or 5 years ago, we had several products, but a monolith. Now, it was nice, cloud native, so all on AWS and all on containers. So we had a monolith on ECS, on Java Spring Boot, with RDS, so a pretty modern stack. But what we started to find as we created different products, the teams were kind of stepping on each other's toes. We had a single data model, lots of kind of clashing. So we kind of went through a system of modernization, and we effectively went to more of a platform approach. So first of all, we decided, let's go serverless first. Let's reduce the operational overhead. We had this idea of going serverless. We tried that out, and we thought, right, let's have a serverless first strategy across the entire organization. And I'll say more about that in a second. The big thing was being domain and event driven. We had this bottom tier of capabilities. Around these are what I would say the core capabilities. These are actually domains. So if I think of customer, the customer domain, that's all our customer information, and our key customer services are in a single domain. And that domain has got several bounded contexts or workloads. A single bounded context is in a single AWS account. And there's a single team who owns that customer domain, one team. So everything customer related is in that one team. They will handle API calls and emit events and receive events around customer interested things. So there's a fully autonomous team. The next layer is the kind of what I would call our differentiators. These are things that we need. Things like billing, how we pay people, how we price, how we track expenses, how we handle documents. These are things that are used by the products. That means that the product focus on the top line can really be what's about the experience and the orchestration of these capabilities. All of these are domains owned by single teams. Each domain will go through a well-architected review as we create that domain, and then continuous well-architected reviews as we evolve. And then it's all kind of a SaaS mindset all the way through. So the second session is, which I love this quote as well by Dijkstra, again, like from 1984. The computer scientist's main challenge is not to get confused by the complexities of their own making. Again, as a lifelong developer, I've created an awful lot of complexity that I probably should have done better at. So let's give our application teams really simple choices. So first of all, I talked about Backstage. We use Backstage as the sort of single pane of glass for the teams. We have a developer enablement team, and all the good work they do in enabling teams is basically exposed via Backstage. So if a team wants to create a new workload, they'll come in here, they'll check a box, and they'll get a serverless API scaffolded for them, all their pipelines set up, all their accounts set up, they'll be all handled for them. So this is the single pane of glass where you can see of all the domains, bounded context, and teams. So, and again, with our serverless first mindset, I don't want to even host this. I want to use this as a managed service. So we use Backstage from a company called Roadie. That's R-O-A-D-I-E. So we use that as a managed service, and we just add all our configuration. And this is our front door. This is our kind of, I'd say, our collaboration point between developer enablement and the dev teams. Second, from a skills perspective, like there's some fantastic stuff created today, some fantastic stuff announced. I don't want to kind of localize that for our teams. I want our teams to use the best practices as is out there. So there's a site like Serverless Land where you can actually see like all the good practice around kind of event-driven architectures, around good blogs. I want our teams to look at best practice and use industry standards as they learn. Second, around simplification, serverless first. It's not serverless only, it's serverless first. If a team are building a new workload, I'd like to say start with these 6 technologies, these 6 services. EventBridge as a single eventing backbone for the whole company. Lambda as compute. Well-architected as their standard. Step functions for any orchestration. Dynamo for storage, and then SAM for deployment. Again, start with those 6. If you need to do something like a commercial off-the-shelf product, then of course fall back to Fargate, or if you need different kind of storage, that's fine, but start with these 6 and then evolve when needed. Next, FinOps. I think this is a really interesting one because each of these workloads are in their own account on the left. So the engineers can create very specific dashboards about how cost is tracked with their workload. So again, cost is your architecture. If you've got an effective and efficient workload, it will be represented in cost. As Werner talks about the frugal architect, like kind of developers can go in and be very specific about their cost. Like I want the engineers to be talking about dollars as they think about cost, not tens of thousands of dollars, single dollars, and be focused on having an efficient workload. That means we can assess the domain to see how well that's performing as traffic scales. And then from an executive level, we can have clear business KPIs and we can track growth back to their technology. I also want teams that own security. So teams do their own threat model. So we use the Stride framework for this. I've been using this for a long time. You kind of want teams to look at their own workloads, do their own data flow diagrams, and think of their own threats. So if you think of something like spoofing, there's like 4 types of components: a data flow, a process, data store, or an external entity. So I think of something like spoofing that applies to process or an external entity. So straight away you can ask a team, how strong is your authentication for that component? And it's kind of coaching the teams to do a data flow diagram, identify their threats and their key mitigations. And believe it or not, that's quite new for a lot of developers. So then, of course, we have the security team to check the strength of the mitigations, but I think it's fascinating for the engineers to actually go through that exercise. The third section is really about, and again, this is a great quote about, an accurate measurement is worth 1,000 expert opinions. It's from Grace Hopper. We talked about well-architected, and again, Matthew said about a lot of people think of well-architected as an audit. I like to think of well-architected as a sort of as a continuous improvement mechanism. So what I will do is say to each team, I want you to create a low-fidelity dashboard, not with like lots of fancy diagrams and stuff, something really basic, like for example in a wiki. Track all the performance times, maybe your cost, reliability, security. Track the stats that relate to the pillars of well-architected. And then every month, every sprint, we'll have someone facilitate, usually an architect, sit down with the team and actually discuss the numbers. So we call this practice SCARP, stands for security, cost, operational, reliability, and performance. And again, it uses the sort of structure of well-architected, but it's a much more kind of, I would say, conversational process where we spend time to maybe ask questions. I think of this like you've heard of a blameless post-mortem after an incident. This is like a blameless pre-mortem. Let's sit and kind of look where we're starting to see a bit of smoke, where maybe performance is starting to go slightly. So it's a great way to actually sit down in a safe space and ask the developers, like, what are you concerned about? And usually people will say, I'm really worried about this Lambda function. It's really slowed down, and we can kind of focus and just share ideas. It's brilliant, and we have this running probably in about 40 or 50 teams within GP, and there's hundreds of other teams running this in different companies. It's a brilliant process. So really why I like this, it's the codification of team mentoring. It's an atomic habit. It says, basically, get to a point where every sprint, you're sitting reviewing your non-functional KPIs. I mean, that can't hurt. Trends, I don't like to compare teams with each other. I don't like to say, well, I spoke to a team yesterday, they're much faster than you. It's like more about the trends. How are the figures trending from last time? And once you start thinking of the trends and the actions, you can see a direction of travel. And then the conversation, this is the most important thing. It's a safe space, so have the conversation with the engineers and make sure that people are happy to share concerns. So let's talk about the workload readiness of if a team wants to create a new kind of workload. The first thing I'd ask them to do when they're trying to get a development account is why. What's the why of this workload? What's it for? What's the KPIs? What's the services, events, etc.? And once we're kind of happy that it's tied to a domain and a business outcome, we'll vend that developer account. Then we'll go through, that's then when a lot of the build happens. So my role as an architect is really enabling and coaching the team through some of these things. I'd like the team then to build a fairly decent, like a production candidate version of this workload, and then we'll request a test account. And as we go through the test account, we start to kind of ramp up some of the quality controls. We'll have our threat model done. We'll have a clear reading in Security Hub. We'll maybe have a performance test run. I'll ask the team, have you looked at your cost dashboard? We'll have a cost intelligence dashboard set up in QuickSight, so make sure the team are aware of that. We'll likely do a well-architected review on the serverless lens. We'll think about what's the acceptance test look like for this workload. Our data schema of events will be logged in our kind of data platform trusted advisor is clear, and we'll have all our deployment pipelines. And it's at that point then they get their test environment. I think it's really important at that point, because once they have the test environment, now there's no longer any access to the dashboard. So a team will vend a test account, and then they'll come back and say, oh, I just need to upload a file. Say, no, you can't do that. We have to automate all access. So it's infrastructure as code right the way across. That kind of jump from dev to test is really important, because it actually simulates production. Once we go through the hardening and test, we'll then request production workload or production account. Again, these are 3 separate AWS accounts. So we'll then tighten up on security scans, make sure Snyk and all our security scans are clear. We'll make sure our observability is live and we're happy with all our dashboards, etc. And we'll review our runbooks. At that point, we'll then vend a production account, and the team can now deploy on demand. They now own this workload, and they run this workload. My role as an architect will be enabling this work as we go through this. And we've got developer enablement, security, lots of different teams will enable the application team as they go through this path. For a brand new team, this seems like a lot of work. Once you go through the cycle a few times, teams get very good at it and can do this very quickly. But I would rather shift left and work out early on that maybe the teams have some places to learn, and then by the time we get to production, they're good to go. So again, I'll finish with, this is a great quote from Adrian Cockcroft: you don't add innovation to a culture, you get out of its way. So I want to kind of frame what we're doing around these 3 things. I call this the ABC of software and people. You want to align on the workload, the capability we're building, figure out the right boundaries through some of our kind of event-driven and domain-driven techniques, and then set the team up to be able to code. So I want to talk through an actual scenario that we've been through this year. So this time last year, I was doing a talk at reInvent, and we were talking about an idea within GP. When I came back, probably mid-December, we said, well, let's have an event storming session to figure out what this looks like. And the problem was, if we're hiring a professional in the country, how do we collect the information, depending on what country they're in, because it's different each country. So we got a bunch of sort of stakeholders in the room, and we kind of figured out what are the key events, and that's the actual board in top right. So we collected the events. This was in January. We put some temporal sequencing to make sure they're in the right order. We then identified the key personas that involved in each. This is using Ben Ellerby's event bridge storming technique. And then once we had that idea, we then moved into your kind of boundary with domain-driven design. We started to split these up into software components, and we start to flow out where these events and personas would actually operate within our kind of system. We then grouped those on the bounded context in the 3 different workloads, which just that natural grouping, again, based on the business problem, not the technology. We then went into the code phase, where we said, right now, well, if it's a new bounded context, how do we build this? That picture on top right is an actual architecture diagram from a bounded context, again, using some of the basic components, services I mentioned. So the team then, probably around about April, start to get production deployments. Like we did the event storm in January, probably 2 or 3 months later, they start deploying software. So you've got Event Bridge, Lambda, Dynamo, API Gateway, step functions, both receiving and emitting in events. Like that's the actual architecture of a workload. Super simple, but I would say we spent most of our time thinking about the business problem and aligning the organization and what this was. And what's really nice about that is we started to go to production around April, May, because again, you've many teams involved here. And I think at the minute, this is now live, this system, and I think for about 14 or 15 countries, which are our largest countries, we're able to run new professionals through this system and collect all the information compliantly using this thing that was basically an event storm. And the nice thing is that the event storm picture is similar to the software picture. And again, that was all run through our kind of key mechanisms. So talk through kind of team, simplicity, measurement, and flow. And that kind of thinks into some of the key learnings. And this for me was, again, learnings for me. In such an emerging market, it's hard to get clarity of purpose because it's changing all the time. So it's really important that the team are comfortable with what they're doing and being able to see the pivots. Challenge, it's really important to let teams fail early and not fail kind of disastrously. So you need those fast feedback loops. This is around flow. For next best action, I mean, service and EDA are still quite hard to learn. So you do need to think about simplicity and focus on the business problem. And then finally, measurement is really important. Well architected is an absolute gold mine, but I see so many developers who maybe have never heard of it or aren't really aware of it. So it's so important to think about that as a continuous improvement mechanism. So in closing, this is something I've been saying for a long time. Like, the code is a liability. Some situations you just can't code your way out of it. You got to think of the whole system as the asset. And for me, platform engineering enables that system. You got to be able to have a big thought about how we deliver software quickly. And I'm glad to say that's something we're doing in GP, where we've got a very high kind of throughput of our software delivery, and it's making a massive change to the business. So I'll pass back over now to
Thanks, Dave.
Matt. Thank you.
So we thought really useful to look at all the work that we're doing at Globalization Partners. And I think for that model of how you're onboarding teams, how you're facilitating them to get up to speed is really, really cool. We'll just wrap up with a few final points to drive home some of the bits that we really think you need to remember if you're in this process. I think Roland mentioned, if you build it, they will come. And we see lots of people who spend a lot of time building platforms without really thinking about who their customers are. A platform team is just another streamlined team, and their customers are the developers, and they have to be working really, really closely, working backwards from their requirements in order to deliver the things that really matter. Team structure really matters, and you have to be deliberate about it. I think it's really easy for businesses to invest in those streamlined teams because it's really closely coupled to business value, but we should be really fighting to make sure we've got investment in our facilitating teams who are going and doing that enablement in how we're structuring our platform teams in order to deliver value as well. And sometimes that's a bit more of a battle.
Yeah, and remember, from a platform perspective, solve for tendency early. Solve for your account structure, cluster, platform as a service, and remember that it's an interaction, as you said. If you build it, they will come, not if you don't build with your customer. And standard automations, so good defaults with some escape hatches so that you can enable new patterns and different patterns.
And I'd say document and education are key. There's a lot of these concepts are very new, so don't assume people understand what some of these things are. So document, lunch and learns, share the ideas, create time to actually discuss these ideas and that space to challenge the thinking. Again, finally, like, someone needs to own the vision. This stuff doesn't happen by itself. Sometimes it's the architecture that really think big about tying all these different things together. It doesn't mean you're in charge of everything, but you can just see the bigger picture and identify potential bottlenecks. So
thanks, guys. We're towards the end of the week, so I recommend some other sessions to check out, but there aren't actually that many more serverless app integration sessions. These are 3 of the favorite sessions over the week. All 3 of these are available on YouTube now, so if you need something to watch on the flight home, these will be some good picks. If you want to go and learn anything more about serverless, I think Dave talked a lot about how they've standardized on a standard set of tools within their platform, so a lot of their Backstage just links out to a site called Serverless Land. That's a site that we build in my team that has a whole bunch of patterns. If you want to go and look at how to use step functions to orchestrate something stateful with a Saga pattern, we'll have a pattern and some documentation around that on Serverless Land. We also have a couple of really good skills badges which have a complete learning path to allow you to get up to speed. If you're building things with serverless and you want to have some best practices ready to go, Power Tools is a phenomenal project that contains a whole bunch of things about how to do observability, logging, item potency support if you're building distributed applications. There's some really, really cool code that's available there that will really shortcut your ability to deliver well-architected software. So thanks so much. Been great having you for our last session of the week. I think we'll be hanging around for another 5 or so minutes outside if you want to ask any questions or want to chat about everything. Hope you had a great time at reInvent. Thank you very much.
Thank you.
Thank you.